Module 5, Augmented Reality, ADAR, Lesson 2, Theoretical Foundations of AR, Simulations, and Gamification. Key principles of ADAR and its distinctions from VR and MR. ADAR enhances the real world by overlaying digital information such as images, text, or effects directly onto our physical surroundings. This integration happens in real time, blending the natural environment with virtual enhancements to enrich the user's perception and interaction with the real world. Key principles of augmented reality. 8R, real-time interaction. 8R enables users to interact with digital elements overlaid on the real world in real time. Enhancement. 8R enhances the user's perception of the real world by adding digital information or media. Integration. Seamlessly integrates digital content with the physical environment. Mobility. 8R technology is often mobile, accessible through devices like smartphones and 8R glasses. Interactivity allows users to manipulate and interact with both virtual and real-world elements. Context-aware. 8R systems are aware of the physical environment context and adapt accordingly. Distinctions from virtual reality, VR, and mixed reality, MR. Virtual reality, VR. Virtual reality, VR, creates a fully immersive digital environment, replacing the real world. Users wear headsets to enter these virtual worlds, often used for training in hazardous tasks or immersive gaming. Mixed reality, MR. Mixed reality, MR, blends 8R and VR, allowing digital and physical objects to interact in real time. It provides a more immersive experience by anchoring virtual objects to the real world for complex interactions. Comparative analysis. Interaction level. 8R. Interactive with the real world. VR. Fully immersive. MR. Highly interactive with both real and virtual environments. Technology required. 8R smartphones, tablets, 8R glasses. VR head-mounted displays. Sensory suits. MR. Advanced 8R/VR capable hardware. Use cases. 8R. Manufacturing, retail, medicine. VR. Virtual travel, training, simulations. MR. Advanced design, interactive learning. Overview of simulation technologies and their integration with 8R. Simulation technologies replicate real-world processes for training, analysis, and decision-making. They range from simple computer models to complex interactive environments with physical feedback. Combined with 8R, these simulations become more immersive and engaging, offering a richer user experience. Understanding simulation technologies. Simulations are used in fields like aviation, medicine, engineering, and entertainment. They create virtual environments that mimic real-world aspects in a controlled setting. This allows for risk-free experimentation, training under simulated conditions, and analysis of systems and behaviors. Simulation technologies. Computer simulations. Programs that use algorithms and software to model real-world scenarios, such as weather patterns, stock market behaviors, or traffic systems. Physical simulations. Use physical equipment to replicate real-world conditions, like flight simulators or medical training mannequins. Interactive simulations. Combine computer and physical simulations, allowing real-time user interaction through various controls or devices. Integrating 8R with simulation technologies. 8R enhances simulation technologies by adding layers of digital information to the physical world. This integration can transform how simulations are used and perceived, making them more intuitive and effective. Integrating 8R with simulation technologies. 1. Enhanced realism. By overlaying digital information directly onto real-world objects, 8R makes simulations more realistic. For instance, in medical training, 8R can project anatomical data onto a patient simulator, allowing students to see beneath the surface. 2. Remote collaboration. 8R simulations can be shared remotely, allowing experts from around the world to join a simulated environment and interact as if they were physically present. This is invaluable for complex system diagnostics or coordinated training exercises. 3. Cost-effectiveness. Integrating 8R with traditional simulations can reduce the need for expensive physical setups. Virtual elements replace certain physical components, which can lower the cost of training and maintenance. 4. Interactive training. 8R can bring static simulations to life. In a safety drill simulation, 8R can overlay evacuation routes or danger zones onto physical space, guiding participants through procedures in real-time feedback. Integrating 8R with simulation technologies significantly advances training, learning, and real-world preparation. This combination enhances the realism and effectiveness of simulations, making them more accessible and scalable across various sectors. As these technologies evolve, their impact on professional training and operational planning will grow, providing more sophisticated and immersive experiences. Gamification strategies and their application in industrial settings. Gamification involves applying elements typically found in game design to non-game contexts. This method is used to create user engagement, motivation, and participation by incorporating rewards, challenges, and fun elements into everyday tasks. In industrial settings, gamification can transform routine operations into more dynamic and engaging activities, leading to increased productivity and employee satisfaction. Key elements of gamification: points and scoring. Employees earn points for completing tasks, tracking progress, and setting benchmarks. Badges and achievements. Workers receive badges for mastering skills or hitting targets, recognizing and rewarding effort. Leaderboards display rankings based on performance, fostering competition and community. Levels and progression. Employees advance through levels as they improve, visualizing their development and skill growth. Gamification strategies and their application in industrial settings. 01. Training and development. Scenario: using gamification in training programs can make learning new skills more engaging. For example, employees might earn digital badges as they complete each stage of a training module. Benefit: this method makes the learning process enjoyable and motivates employees to complete their training programs, enhancing skill acquisition and retention. 02. Quality control. Scenario: implement gamification by setting up challenges or competitions among teams to maintain the highest quality standards in production lines. Benefit: gamification can increase focus and diligence, as employees are not only motivated by their regular duties, but also by the reward system that acknowledges their attention to detail. 03. Safety compliance. Scenario: reward points can be awarded for following safety protocols. Achievements can be set for days without accidents or for proactive safety checks. Benefit: enhancing compliance through gamification helps maintain a safe work environment and reduces the likelihood of accidents. 04. Innovation and problem solving. Scenario: challenges can be created where employees submit ideas for process improvements, with rewards for ideas that are implemented. Benefit: this encourages continuous improvement and active participation in the company's growth, fostering an innovative culture. Conclusion: gamification in industrial settings is a strategic approach to enhance employee engagement, improve training outcomes, and foster a proactive work culture. By integrating gamification, industries can boost productivity, job satisfaction, and employee retention. As companies evolve, these strategies help meet the changing expectations of the workforce, ensuring employees stay motivated, skilled, and committed.